Hello everyone, so in this video, let us talk about another medium level problem from LeetCode. The problem name is design the bit set. So let us talk about the problem statement first. The bit set is a data structure that compactly store bits. Okay, so we have different bits, and if you want a bigger data structure that compactly hold these bits and you can do manipulation around them, then a bit set is a very perfect data structure that we can use. Now you have to implement the bit set class, which has different functions that are done on the bit set. Okay, let us talk about all of these functions one by one, and then you have to implement them. So the initial function is to initialize a set of bits. So this function will initialize a set of bits all equal to 0. So let's say I have 5 bits or 100 bits and so on, depending on that. So I will initialize, let's say 10 bits, 5 bits, depending upon the size that is given to you as an input in the input params. We will initialize us, let's say whatever like bit set of this number of size, all initialized to 0. Then this fixed function will take an index, and what it will do is that it will update the bit at the given index, that is this index, to 1. So let's say I have the bit set, the data structure, and I will tell you that update the 5th bit to 1. Now if the value is already 1, it will not change, but if it is not 1, if it is, let's say, equal to 0, then I will update it and I will make it equal to 1. Cool. Similar to unfixed. Unfixed means that whatever index that is given to you, make it 0. If it is 1, like the bit is equal to 1, then make it 0. And if it is already 0, then don't do anything. Now flip means that you have to flip all the bits in the bit set. Like if it is 1, make it 0, 0 equal to 1. Okay, then that is the overall idea for all the bits in the bit set. Then all will check that whether all the bits in the bit set is equal to 1. 1 will check that there is at least one bit in the bit set that is given to you which is equal to 1. So all the bits that you have in the bit set, if at least one is equal to 1, the value is equal to 1, then answer is true for this boolean function. Count will tell you how many ones are there in the bits that you have, the number of 1 bits. And toString will actually help you to convert, or actually take that bit set that you have and print out that complete, let's say, state in a string format. Okay, that is the overall idea that you have to do. Now the overall thing is that the total size of it is pretty much large, 10^5, and at most 10^5 calls will also be done. So what you can do is that the overall size 10^5 and the overall at most calls will also be 10^5. So you cannot do this in a very, let's say, brute force way. You cannot just iterate over the complete string one by one. All these operations to, let's say, count out, or you can say, let's say, toString, one, all of these operations cannot be done in O of n. So you have to understand that depending on the problem statement. If you try to do all of this in a very brute force, it will give you a TLE. It will run for small test cases, but it will give you eventually TLE. So what you actually have to do is that you have to understand that what is the need of the problem statement and how can we optimize it. So let us try to optimize it according to the problem statement. The first thing is, let's take a small example, then we can try to use it. So let's say we have a string. So in the end, we have to print a string. So why not take it as a string only? Like initially I thought to make a Boolean vector in which I have a Boolean, so it will be only 0 or 1 and it will be vector. But what you eventually have to find out is that in the end, because it's a Boolean vector, you have to convert it to a string, because every category you have to iterate over. It is 10^5. So you have to do a complete 10^5 iteration, convert it to a string, and then print it out, which is a bad idea because in the end you have to print out as a string only. So why not keep it as a string only, so that in the end, if you want to print out, you directly just throw out whatever string that you have. Okay, that is a very cool idea. So don't make it as a Boolean vector. It's bad for that because 10^5 size is there. So you eventually have to make a string or vector only. You cannot make it anything else. Okay, let's talk about that. So let's take a string of size, let's say 6. So what we'll eventually have to do is that, let's say that we have a bit set function and that will create a string of size 5 and that is stored in BS. So let's say that it is a bit set, so we have named it at BS. Okay, now what is this BS flip and why is this important? We'll talk about that in just a minute, but just focus on here. Okay, then we have what we'll eventually have to find out is that all these functions to check out whether all the bits are 1 and all, like how many ones are there. For that, what we can eventually can do is that we can keep a variable that is count equal to 0. And whenever, let's say, this function is called, that is fix, this fixed function will make any 0 equal to 1, and this unfixed will make, let's say, any 1 equal to 0. So if I am, let's say, converting any 0 equal to 1, then which means that the number of ones in this string is increased. Pretty much simple. So let's say I'm converting this to equal to 1, or that this is equal to 1. Or if I'm converting this again equal to 1, then the number of 1 will not change. And if I'm like it is already 0, and if I'm making it again 0, so the number of 1 or 0 will not change. But if it is equal to like let's say 0, and if I'm making it 1, the number will increase. And if it is equal to 1 and I'm making it 0, number of ones will decrease. So for all these two functions, fix and unfix, will actually help us to know whether number of 1 will increase or decrease in the string. So we can keep a count of it. And when we eventually have to find out that whether all the bits in the string is equal to 1, we can just check the total size and the number of ones we have in the count variable. If they both are same, then which means that all the let's say bits in the bit set is equal to 1, because let's say the total count is 6, and the total length of the string is 6, which means that all the ones are there. The total number of ones in the string is 6, and the total number of characters in the string is 6, so which means that all the characters are 1. So that is answer, like that is correct or not. You can directly just check out in O of 1. For this one function, that whether at least 1 is there, you can just check out using this also. Count means how many ones are there. You can print out it, and converting it into string, you already had a string, so you can print out. So why we use a BS flip? The thing comes down to this function, this flip function. If you want to now flip all these bits, let's say all the bits are like this, 1 0 0 0 1 0. Let's say this is the string, and if you want to flip this string to, let's say, a new string in which all the bits are flipped, so in that scenario what will happen? You will take, like, this is 0 1, let's say 1 1 0 1. So what you can say is that all the bits are flipped, which eventually means that you have to again do a iteration from left to right over the complete string. But that is bad. Why? Because I have told you that I cannot do an iteration over the string again and again. So how can we do that? For that scenario, if I somehow store the flipped version of this string also, then why not? It is good. So what we'll do is that initially when we create a string that is, let's say, initialized to 0, this string, I also create a just a flip string of it, that is this string, like, which is all equal to 1. So if we have created a string, let's say, of equal to 10, all equal to 0, I will also create a string equal to 1 also, all the string, all the characters of it. So all the zeros and all the one string, two strings are created then. That is good. Now if that is created, what string I am on? What string I mean that whether the string I am on is all the zeros 1, or I am on the string that is all 1 1, which is like the flipped one. For that I also created one more variable that is flipped, whether I am on the flipped string or the actual string. So flipped is false, which means that I am on the actual string now. So let's say this is the function. Now if I call this flip function means that initially I am on this function. Now my arrow should go to this function, which means that now I am pointing towards this string. This string means that I have, in O of 1 only, I have flipped the string. Okay. So now if this function has, let's say, count number of ones, this string is just the opposite of it. So this number has n minus count number of ones. In O of 1 also, I have changed the number of ones as well. So that is fine. And all the functions can also be used. I have the total count. I can find out all the other ones. The only problem now is to call this fixed function and the unfixed function. How can we update all these things? I have to only ensure that the only thing that you have to ensure is that for both of these strings, it should be in the very flipped state. What I mean by this is, let's say I am on this string. Let's say on the first string. Now, if I am given an order to flip this bit from 0 to 1, if it is ordered to make it 0 to 1, the other should become 0, because this other string should always be a flipped version of the above string. Okay, so if this is made to 1, then it should become 0. And if I am ordered to make this 1 again, which means that I have not changed anything. So if I have not changed anything, this should also be not changed. Okay, that's the overall idea. If now I am given the order to make it 1, make this 0. If I am given the order to make this 0, make this 1. Now, if I am on this string, if I flip the string, I am on this string. I am given the order to make this 0, but now make this 1. So what you understand is that the other string will always be a flipped version of the other string. Okay, so that if I do an operation on this string, if the operation is successful means that if it is a 1 and I want to convert it to 0, then the above one should also be converted from, let's say, 0 to 1. But it is already 0 and I want to make this again 0, so which means that it is already 0 and the operation of it make to unfix it is again 0. So don't change the above one because we have not done anything. Okay, that is our idea that you have to do to now use this function. Let us not talk about the code part now. So that's our idea that we use. So these are the two strings, BS and BS flip. That is the just flip version of this. Okay, and then this is the flipped and unflipped function. We'll just talk about that. This flip function will just flipped out. So if I am, let's say, on the flipped string, I will just let's say if I'm on the first string, then we'll go to the next string. So this will just flip it, and the total number of count of ones will just becomes the total string minus the original value. That is just the flip of it. This all will return the total number of ones, and this will always stored in all like one count. Use that, use that, use that, and use that. So if I am on the, let's say, flipped string, then I will print out this, and if I'm not, like if I'm the flipped string, then print BS flip. On the original string, then it is just BS. Okay, so all of them will be used. All this information is stored here. Okay. Then how these functions are worked? So what you can say is that, let's say I want to fix it, like I want to make it 1. So what you can say is that if I am on not the flipped one, that is I am on the original string and it is already equal to 1. So I'm the original string and I want to fix it, which means that I have to make it 1 and it is already equal to 1. Then I have to do nothing. So return, just return, but don't do anything. And again, if I'm on the flipped string, that is I'm the flipped string and it is already equal to 1, then again don't do anything. But if I am on the flipped string and if it is all like it is equal to 1, let's say, sorry, it is equal to 0, then I have to flip it. So if I want to flip it, then I have to like make it is equal to 1 and the other equal to 0. So because, then flip both of these strings, same index, similar to other thing as well. And then it's an unfixed function, the same idea which I've told you. And all the other things are same. So I'll just scroll through the whole code again so that you can pause this video and try to see the code as well if you want. That's it. That's the idea and the code part for this particular problem. If you still have any doubts, you can mention in the comment box of this particular problem. I will see you in the next video coding, and bye.